Okay, hi everyone. I'm here to talk about the topic about the channel loss challenge in the complicated OAM v1.0 system. But I think the topic may be wrong considering we just saw the OAM 2.0, UVB 2.0. So I think we can skip about the complicated part. Okay, my name is Bryan. I'm from company Wiwynn, and we have a booth on the A13. And today I'm going to talk about a little bit our experience in the OAMv 1.0 and the UVB v1.0 system. So I like to take this chance to be grateful and thanks for our company to let me be here to share about our experience in the OAM system, OAI system. And also, I'd like to thank the OCP to have this summit to gather people around here. It feels like we have made some progress about the future technology, and it's good to be part of it. So I will share some experience about how we developed the UVB v1.0 with the OAM v1.0 systems, about the challenge we faced for the SI point of view. The picture shows here is the spec from the UVB spec, and you can see the bar diagram here, and you can see the blue part as 8 OM, and you can see the lines between them. The red line means the power, and there are high speed between the OM and the host and to the QSBDD. As you can see that, the yellow line means the PCI link, and the green line means the SerDes connected between the OM and the QSBDD. And you can also see between these lines have the retimer recommended by the OCP spec. So you can see that the yellow part is for the PCI retimer is recommended to be put on the UVB. And also there's the green part for the SerDes retimer to be put on the UVB as well. But there's another high speed. It's not been represented in this picture. It's the high speed connection between the OEMs. So make sure that the OEM can be connected together. And that's the part I want to discuss about the channel loss challenge between the OEM. This looks familiar from the previous talk, that this is defined in the UVB v1.0, the loss budget, as Song just mentioned before. So you can see that between the two OEM, the green part and the red part are two OEM. So OCP has defined the channel loss, as I just mentioned, as 30 dBs. So the OEM part keeps the 8 dBs with each part. So the connection between OEM have a loss as the 40 dBs. So as the previous present, you see that the OEM, between the OEM, there are long traces. So it's a little bit challenging that you face the 40 dB right here. So that's what I want to talk about. So how we made possible to achieve the 40 dB loss challenge. So this page, I want to share this in our experience in two ways. It's the material solution or the layout solution to achieve that 40 dBs to make sure that the loss dB challenge can be solved. The first one is the material solution. Of course, you know that the PCB material means a lot to the loss budget. So in the OCP spec, they have defined and recommended that the UVB material can be as ultra low loss. And if you would like to have a more loss performance, that you can use the ultra low loss advanced material to make sure that you have a more loss budget of that. Sorry. And except for the PCB material, that you can think about with the same material, but a different stack up they still have chance to improve the loss of the PCB. So with the thinker core, considered that you can have a lower loss. But however, the thinker core means to the signal trace need to be wider to maintain the same impedance control. So here you need to consider about how your layout trace need to be placed. Since the thinker core means the wider the signal trace will be, and that will be a limitation between OAM trace to be routed. So the material of PCB and the thinker core of stack up need to be considered together. And the next one, and the high resin contain glass type and the low inch can also help you to improve about 9% of the loss budget. But all of this considered takes cost increased. So either of this one can improve the loss performance, but also you will have the cost increase. So it's the trade-off to think about how you want to make your loss budget or how you want to make your PCB cost. And the next one that you can also do a little bit more about your layout solutions. For the layout solutions, you can have a larger pitch of your high-speed routing. So that will lower your loss a little bit. But again, it will impact the signal routing as well. So you need to consider them all together, not just one item by another items. And the next one is the back drill and the Bryan via and the Barry via. Both of these via design is tend to lower the via stop of the signal. In this way, you can lower the signal loss as well. But again, this will increase the layout cost as well to the PCB as well. And the next one, via size and anti-pad optimization can also lower the signal loss, and it will decrease the refraction of the signal and makes the signal loss be lower. So with all these strategy considered, you can have a SI guaranteed and channel loss guaranteed PCB. So that's how we do it on our UVB solution for V1.0. But Wiwynn, as a solution provider, we are not just thinking to provide performance promise the PCB, but also we think in the terms of the system level or rack level. So you see, once you have an OAI system right here, but you still need to connect it with the host side. So in this picture, that shows the you have a OAI system here, and you need to scale out with the blue line, and the host you have to connect with the green line. And between the host and the OAI, you still need to connect it together with the PCIe cables. So there is a simple challenge in the rack level. You will have to consider many cables around the rack with UVB and the host to be connected together. So we think, why not combine together? So if we want to combine the OAI system on the left side and the host side on the right side, so what we can achieve that? So the easier way is to use the PCB connection right here, just to connect the host and the OAI system all together. But the loss budget will be out of spec, so you will not be able to use that with SI performance. So this is not a good way. So why not use the cable? The loss budget looks perfect. But as I said, Wiwynn as a solution provider, we think that you have to service benefit for your system. So with the cable solution right here, the OAI or the host will not be draw serviceability benefits. So this is client face as well. So Wiwynn has think about to connect it with the OAI and the host with both cable and the PCB, and also we have the PCI retimer on it. So with the PCI retimer on it, we can have both upstream between the host and the PCI retimer has the SI guaranteed, and also the downstream between the PCI retimer to the PCI switch. So both sides, we can have the SI guaranteed. So we try to put this all together with a good SI guaranteed system. So in system point of view, that you can see that the gray part, the cable is no longer exist, and we can combine the UBB and the host all together in one system. So you can have a less cable assembled in the rack level point of view. That's what we do in the Wiwynn. So in this picture, you can have a clear picture for the PCI routing right here. So the bottom level is the CPU node, and the top level is the UBB node. And between UBB and the CPU, we have the PCI retimer to be connected together. So the PCI trace is SI guaranteed in our systems. So let's take a peek of our Wiwynn OAI solution, SV600G2. So we have 8 Gaudi 2 with from Habana put inside, and we have 2 CPU in it all together in these systems. So if you are interested in our system, we have the real system at our booth at 13. And if you are more interested in how we can provide the solution, you can visit our website. And if you are interested in the OAI spec, you can visit in OCP website. So thank you. Any question can be answered at our booth at 8:30. You're welcome to come here. Thank you.